exercise towards the end. You don't really have to, if you want to scoot back to it, it was like number 10 or something on class number 1. It was the always, sometimes, never. And your tables, we had to decide whether each one of those statements were always true, sometimes true, and never. That was Monday. And I let this go by, hoping that maybe someone might come up and say, but, you know, is that one? And I'll tell you which one I let go by. So when we did this one in class, every single table told me always, 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 all 5 tables. And I'm going to tell you, I'm going to destroy you right now, oh no, that the answer is sometimes. Huh? So can anybody think of a counterexample that would make that only sometimes true? Cooper? 0, right. I know, come on, 0. 0 is the one number that is its own opposite and is its own absolute value. So you can't say that that's true for every single real number. It's true for every single real number except for 1. So that's why you have to say sometimes there. Okay? All right. Now, class number 2, which was just Wednesday, we're not going back too far. I think if you recall, we were doing that division problem. And one of the things we were asked to do was to identify the excluded values from the domain. So we started off by factoring the numerators and the denominators of this. And we said, okay, what's going to make each denominator 0? What values? And then we excluded them. So we noticed, as it's written right now, as a division problem, it couldn't be plus or minus 4. Then we changed this division problem to an equivalent multiplication problem by finding the reciprocal or inverting or flipping, however you want to refer to it. We changed division to multiplication by the reciprocal of this particular fraction. So then the denominator of this multiplication problem was x plus 5 and x plus 1. So the question was, I think it was from this class, and I said we'll get back to it on Friday. Am I like imagining this, or did we have that discussion? Okay, good. So initially you say, oh, it's just 4 and negative 4 that aren't allowed into the club called the domain. But now when you look at this problem, which is equivalent to this, we still can't have 0 in the denominator. So now you've got to add 2 more values to your excluded values, and that's negative 5 and negative 1. Okay? So this is from class 2, number 9. That's this problem right here. Okay, so for the excluded values, you actually have 4 values. Now, to save you frustration with my math lab, when you get to this part of your homework and it asks you to put in the numbers that are excluded, they want you to write them from smallest to largest. That's the little thing. So when you write these 4 numbers into my math lab, you'll want to enter them like this. Negative 5 is your smallest number, negative 4, negative 1, and 4. That's the set of numbers that's excluded. Okay? So these 4 numbers. If you write them in a different order, I think it's going to give you the wrong answer. It does, yeah. Okay, so for my math lab, you want to go from smallest to largest. Okay, anything else? Did everybody get answers for this table activity here, these 3 questions? Let's take a look at what we got. Table 1, what you get for these 3? Just go right down the line. Okay, and table 2, what you get? False, true, false. Table 3. false, so that's okay. And table false, true, false. And the last table? False, true, false. Okay, so one of the things you have to do if it's false is you either have to change the sentence or equation so it's true or show a counterexample. So someone want to tell me one way that they changed A, which I agree it is false. Yep, Cooper? It's true if x equals 1, because that would be 6 plus 1 over 1 equals 7 over 1. Yes, that's one way to do it. And I don't think I've ever had anyone come up with that, at least not as an example. That's good. Okay, some other way? Connor? Yeah, put 6 over x plus 1 over x. They now have the same denominator, so you can add the numerator. Okay. And yes, this is true because the consecutive integer that follows -4, to get consecutive integers, you add 1. So -4 plus 1 is -3. And to reduce this fraction, you find the greatest common factor in the numerator. That's always one of the factoring techniques that students want to forget about or kind of ignore. So -3 is a common factor here. So isn't +3, but I pull out a -3 to keep the number in front of y positive. And there's my 1, and -3 equals -3. Now this last one we had, table 1 said it was true. To square something, we multiply it twice. And now to do this multiplication, we have to use FOIL. And when we use FOIL, this quantity right here is called a perfect square because we're squaring it. And when we get a perfect square, we always get our inner and outer term to be exactly the same. So when we use FOIL on this, we get 4x squared plus 12x plus 9. Okay, so this is not correct. And what happens is students confuse this problem with something like this. When you have a product raised to a power, that's when the power comes down and applies itself to each of the factors. Okay, so this is a product. It means you're multiplying. Here you have a binomial, means you have two terms. You'll see a plus sign or a minus sign. Totally different area of mathematics, how you approach the two of them. Okay, so exponent rules only apply to multiplication in parentheses, or if you had division. Then the exponent applies itself to numerator and denominator. But if you had adding and subtracting, then you just go back, you fall back on what it means to square something, and then you multiply out 2x plus 3 times 2x plus 3. Okay, so given the fact that we sort of ran out of time a little, well, we didn't run out, but I wanted more time to work with GeoGebra, I kind of feel like people know how to plot points, and so I'm just going to skip this if this is okay. Okay, if you need me to go over it, I will, but I think I can I assume that you know how to plot points in a plane? Okay. All right, so let's go to, we're going to look at 3 ways to graph equations today. We're going to do it by brute force by hand, and then we're going to do it with our graphing calculators, and then we're going to do it with GeoGebra. So those are the 3 ways we're going to graph equations today. Okay, so when we graph an equation in 2 variables like this one, y equals 4 minus x squared, one of the ways we graph it is to generate or come up with a number of at least as many points, x comma y, that satisfy this equation so that we can see the shape of whatever it is we're asked to graph. We may not know the shape of the graph by looking at this equation. Some of you may know right now what kind of shape that's going to have. Some of you may not. So the key idea here is that every single point that satisfies this equation is also called the solution to the equation. So this is a solution to this equation. The graph represents your infinite solution set because there's not 1 or 2 or 3 or 4 or 5 or 6 or 7 solutions. There's an infinite number. So when you connect your points with a curve, you're showing all the possible solutions for that equation. So one way to do it is you just list a bunch of numbers for x, which is called your independent variable, because you're really free to pick whatever numbers for x you want. Once you put an x and you plug it into this expression, y is determined. So the value of y depends on x. So we call y the dependent variable. Okay? Independent and dependent. So if I chose 0, I'd plug 0 in for x squared, and I'd have 4 minus 0. My y value is 4. So then I write my point as 0, 4, and I go over and I graph it, 0, 4. And I always label your points with the coordinates. Okay? And I can do the same thing here. 4 take away negative 3 squared. I want to note something for you folks. Whenever you are raising a negative number to an even power, you must put it in parentheses, because negative 3 squared does not equal the quantity negative 3 squared, the number. This says the opposite. This really says this. So this is negative 9 and this is positive 9. So when we use our quadratic equation later on to solve quadratics, when you're substituting negative numbers and it's being raised to the second power, the fourth power, any even power, please put it in parentheses. So this says 4 take away 9, which is 5. So my point is negative 3, negative 5. So I go negative 3 to negative 5. There's a point. Same thing here. I put in negative 2. I square negative 2. I get 4. 4 take away 4 is 0. So I have negative 2 comma 0. 1 minus negative 1 square is 1 minus, 4 minus 1, which is 3. So I'm up here. And then I do a similar thing below. And if you do your calculations out, you'll notice you'll get exactly the same values as you did a few minutes ago for each of those points. So we have 1, 3, 2, 0, and 3, negative 5. Okay, so again, I'd like you to label these points on your graph. Okay, now when you join those points with a smooth curve, you are representing the entire solution set for the equation y equals 4 minus x squared. Notice how I put arrows to denote that this continues to go towards, all my y values now are going towards negative infinity. Continues. Every time you draw a graph, you want to put a title on it. One of the ways you put a title on a graph of an equation is to label it with the equation that you've just graphed. So you always want to label your graphs with the equation that it represents. Your graph is representing the solution set to this equation, all possible solutions. Any questions on that? Okay. I'd like you to do the next one at your seats. It's the absolute value of x. I'd like you to plot that. If you have any questions, use your flags and I'll come around and help you out. It looks like a V, doesn't it? And what do we call this point right here, 0, 0? What's that point called? Origin, right. Okay. So if you notice, when we defined absolute value in our first class, we defined absolute value like this. X, if x is greater than or equal to 0, and the opposite of x if x was less than 0. So now we're saying that y equals the absolute value of x. So notice we actually get two different graphs. If we substitute y for absolute value of x, we're saying that the absolute value of x is two different straight lines. It's the straight line y equals x, when x is greater than or equal to 0, you're just a straight line right through 0 with a slope of 1 with a positive slope. But when you're a negative number, look at what type of line you are. You're a slope with negative, you're a line with slope of -1, which is this one. So you can see that to define the absolute value, you needed two different pieces. You needed the line y equals x, and you needed the line y equals -x. That's why we're going to call this a piecewise function when we get to functions. That's the first piecewise function we look at. Okay, so let's take a look at x and y intercepts. So the x-intercept is when your x-axis gets in the way of your graph, just like when hopefully someone's going to intercept Peyton Manning this weekend, if you're a football person. All right, so the x-axis gets in the way of the graph. Your y value is 0. So to find the x-intercepts for any particular equation or graph, to find the x-intercepts without having to draw the graph, if we look on our graph, we can pluck them right off. For example, here are our x-intercepts, -2, 0, and 2, 0, because notice your x-axis has gotten in the way of your blue graph. So these are our x-intercepts right here. Similarly, the y-axis gets in the way of our graph at 0, 4. So this is called your y-intercept. So if we have a graph, we can actually, most of the time, we can look at it and at least tell exactly what our x and y intercepts are, or at least be able to estimate them if there's some kind of funky number like 2.134, 0. Okay, we would estimate it. All right, so but if we wanted to find our x-intercepts just by looking at the equation, if we wanted to do it algebraically, let's see how we would do that. So here's our equation, y equals 4 minus x squared, and I want to find the x-intercepts. How would I do it? What would I do to find the x-intercepts? Make y 0. So set y equals to 0. So that would be my first step. And now I'm asking what values of x is going to make y equal to 0. So we're really solving a little baby quadratic equation here. And to be safe, a lot of times people just look at that and say 2. They always forget the other one. So to be safe, if you factor this, because this is a perfect square and that's a perfect square, and if you remember, these can be really easy to factor. 2 times 2 gives you 4. X times x gives you x squared, a plus and a minus. This way you're guaranteed never to forget both of your solutions and both of your x-intercepts. Because when x equals -2, this becomes 0. And when x equals +2, this becomes 0. So our values for x are plus and minus 2. And then we just create our two x-intercepts by writing them as the coordinates 2, 0 and -2, 0. So when we want to find them algebraically, we set y equal to 0 and we solve the equation. Solve for x. Okay. How about when we want to find the y-intercept? Someone else? How do we find the y-intercept? William? You set x equal to 0 because your y-intercept has x 0, and then you solve for y. Those are kind of nice and easy when your equation is already solved for y. So you say y equals 4 minus 0 squared, y equals 4, and then you pop that right up there into the ordered pair, and you're all done. Okay. So I think that that should be a review of 096 material or intermediate algebra. Okie doke. So let's see how we do all of this on our graphing calculator. So pull out your graphing calculator. Okay, so the first thing is how to enter any equation into your graphing calculator. Okay. You're going to turn your calculator on and clear it out. from anything that second quit. Just clear the whole thing out so it can be nice and fresh. You hit your y equals button, and you can see I already have this equation in there. 4 take away x with the little caret square. So I put that into the y equals. Y1 button. Now to graph this, you want to tell it what window you want to graph it on. Your standard window is zoom. You hit your zoom button and you hit 6. And that will graph it from -10 to +10 on both your x and y axis with increments of 1. So it graphs it. Both your axes have all of your positive and negative integers between -10 and +10 on both axes. So let's take a little picture of that. We'll take a little picture. We'll put it down here so you have it for later. All right, let's just move that over here. So there's your picture. All right. So if you want the standard window, this is what the standard window looks like. And this is how we write our standard window. And you'll have something on your first quiz about this type of notation. So right now, let's see if we know what this means. So this represents my x minimum value, minimum. So when you're looking at this graph, you know you're -10 out there. This represents my x maximum value. So that means you got 10 out there. And this tells you you're incrementing by 1. So you're looking at consecutive integers, -9, -8, blah, 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 blah. 8, 9, 10, 0. Okay, so you're incrementing by 1. Same is true for the next box that has your 3 numbers in it, except for it's your y minimum value, your y maximum value, and your increment by 1. Okay, so this is 10 on top and -10 on bottom. Okay. So suppose you wanted to change that. Suppose you wanted to look at this graph just between -3 and +3 for your x. Suppose you wanted to look at -3 to +3 and every half step, half value between -3 and 3, and you wanted your y axis to stay -5 to 5 and every 10th. Let's suppose you wanted to look at that. Suppose this is what you wanted your window to look like. Let's see how we would do that on our graphing calculator. So again, we go to our graphing calculator, we hit window, so we want to change what this window looks like. Now my x minimum is -3. My y maximum is +3, and now my scale is going to increment by 0.5. My y minimum is -5. My y maximum is +5, and my, let's just keep it at 1. And we'll keep my scale at 1. All right, now when you hit enter, your graph's going to look a little different. Okay, because now I'm only going from -3 to 3 and from -5 to +5. Okay, so that actually looks kind of like wider and fatter, doesn't it? It's kind of like you've zoomed out. I mean, in on it, right? You've zoomed in, so you only see a smaller piece of it. So that would be the window we just made up. I could make up any window. Now later on, when we're graphing different types of equations, you might get a little frustrated because when you hit that standard window, you won't be able to see the whole thing. And that's what you have to do. You have to go in and play around with the window a little bit until you can see your whole graph. And sometimes it's a little frustrating, but with a little bit of practice, you really get the hang of it. It really is a bit of an art, to kind of get it where you want it. But I remember when I first started using the graphing calculator, I was like, oh no, what's this window going to be so I can see this graph? And sometimes they were really complicated. But it won't take you too long. We won't be looking at anything that's too outrageous. So any question at all about zooming in with the getting the standard window and what this notation means. Do you have any questions on that? Okay, so let's see how we actually saw how to generate the a table of values the other day in class. So let's do it quickly for the absolute value, because that's kind of a tricky one to find. So I want to turn off this equation. To turn off this equation, you can either clear it out or you can just move your left cursor over and hit enter. If that's not blinking, it's not on. So now, how do we get absolute value? There's two ways. One way is to hit the math button right here. When you hit the math button, you go over to NUM, and the very first thing under NUM is absolute value of, and then you just hit enter, and you just throw in your X. You don't have to close your parenthesis. I just do it for closure, no pun intended. Okay, so that's one way to get your absolute values, to use the math button, scroll over to num. It's probably well, it depends on whether you think it's the easiest. The other way to get it is you hit second and then look for the word catalog. See it down here above the 0? You see the word catalog? When you hit that, it's the very first one in catalog, ABS, absolute value. You could hit that as well. So those are two different ways to hit the absolute value. Okay. So let's suppose we want to generate, first we could look at this graph, and again we could do the standard window, zoom 6, and there it goes. There's the absolute value we just looked at. And again, if we wanted to generate a list of tables, a list of values, you can just set your table, and you can say, well, I want to go from -3 and I want to increment by 1. This time, instead of asking it to give me the Y value, I just want to do it automatically, and that's what the auto button means, because we did the ask the other day in class. And now when you hit second table, there are the 7 values that you just graphed at your seats. Okay, the 7 different ordered pairs that you just graphed a few minutes ago. Okay. Any questions on that at all? If you want, again, to look for a very specific answer in your window, the key is changing that auto to ask. And then you can ask it to find the absolute value for any X value. So now I could say -25.32, and there's the answer for -25.32. So that's the difference between the ask button and the auto button. Any questions on that? Okay. So the very last thing I want to show you is how you find your X and Y intercepts with the graphing calculator. To find your Y intercept, it's what we just did a second ago. We want to know what the value of Y is when X is 0. So as long as you have your table set with the ask here for your independent variable, you just go to the table and you put in 0, and out comes 0, because it's finding the absolute value of 0. If we want to change our equation, we come down here, we turn off the absolute value for X, and then we go up there, we turn that equation on, and now when we ask for the value of 0, we get 4, okay, because we've just switched our equation. Right? The other thing is, in case you didn't know this, you can turn on more than one equation at a time. Let's turn on 3 different equations. Let's turn on, let's make up another equation. X squared plus 3x minus 10. So I got 3, oops, that should be X. So now I've got 3 equations in there. So now when I hit the table button, notice how I have 3 columns. You can't see the 3rd column, but there it is. You just cursor over. So now I can put any number in that I want for X. Let's put the number 5, and it's going to give me the answer for all 3 equations. So my first equation was 4 minus x squared, right? When I put 5 in for x, I get -21. My second equation was the absolute value of x. Absolute value of 5 is 5. And my third equation was that big long thing, x squared plus 3x minus 10. And when I put 5 in, I get 30. So you can actually look at the values for many different equations, and it will all depend on whether you have them highlighted or not right here. Okay. So that's how you find your y-intercept. Your x-intercept is a little different because your x-intercept is where you're trying to find the x values for when y is 0. So think of that. Y is 0. The value of your expression is 0. So you hit second calc, and notice number 2 is 0. So if you go down there and you hit 0, this is going to graph 3 things right now. Why is it graphing 3 things? Because I have 3 equations. So this is going to get really messy. So let's shut off 2 of them. Let's shut off, well, we've played around with that first one enough in absolute value. So let's play around with this last equation I just popped in there. Okay, can you see the bottom of that equation? No, but if you really needed it, we don't need to see the vertex, which is the turning point of this parabola. We don't need to see it because we're trying to find the x-intercepts. But if you wanted to see the whole thing, you just go into your window and you make your y minimum value a little bit smaller, like this, -20. And it's a guess. I don't know what it is. Hey, I get to see the whole thing. Really cool, all right? So now to find the x-intercepts, I'm going to show you a little different method than what your handout says. Okay, your handout says to hit the trace button and move this cursor around till you get to a point, you know, just bigger than where your x-intercept is, and then you move it around and you're just smaller, and it's kind of a pain. So all I'm suggesting doing is it looks like this x-intercept is the number 2. So let me take off that trace if I can. Can I take it off? I'm going to hit 0 again. Second calc, 0. And I'm just going to show you my method. My method says just find a number to the left of this point. Any number will work as long as you don't go past your other intercept. So a number to the left of that point, 0's really good. I don't have to mess around with this with the cursor. All I do is hit 0 on my calculator, and it's putting 0 in as the left bound. Then I hit enter. Then I find a number a little bit bigger than that number. I'm going to say 5, 4, 3, doesn't matter, 5. And I hit enter. And then you'll always get guess, and guess you just always hit enter. And now it's going to calculate for you the first x-intercept, 2, 0. Okay, so let's get a picture of that. So notice all I did was just enter in a left bound, a right bound. Okay, and there's my first x-intercept. Now let's get my second x-intercept. My second x-intercept looks like it's what, -5? So I hit second calc, I go down to 0, and I say, to the left of -5 is -6. Hit enter. To the right of -5, I don't want to go past this other x-intercept. Oh, -3 looks pretty good. Hit guess, hit enter, and it calculates my other x-intercept for me. Okay, so you can play around with the cursor if you want, like the instructions say, or you could use this particular method. One of my students showed me how to do this, and I was forever grateful. So there are the 2 x-intercepts. Okie doke. Any questions on how to use your calculator to find either the y or x-intercept before we move on? All right, now we're going to graph with GeoGebra. So before you pull it out, I want to do a little demonstration for you, show you some of the things you can do. So put your graphing calculators away. So we started off the class with this equation, and we graphed it by hand. We've looked at it with our graphing calculators. I want to show you how you enter an equation with GeoGebra, how you change the window, how you generate a table of values, and how you do some intersections. Okay, so I'm just going to do a demo. You will have like 30, 25 minutes to play with this today, and I'm going to help you all out as needed. I'm first going to show you if you have your own, let me get rid of this, new, don't save. If you have your own, I just want to get the spreadsheet out of there because that doesn't usually pop up. If you have your own laptop or a computer at home, or you need to use a computer at GCC, you're going to want to download www.geogebra.org. Okay, the full-blown version. If you have a tablet or a Chromebook, you're going to be using the app. And with your full-blown version, you'll be able to right-click and left-click. And if you're not used to having a Mac, some of you don't have a Mac, it's gonna be a little tricky to right-click on here. Last semester, we didn't even think we could right-click, and then we discovered that if you use your two fingers right in the middle of this little pad right here, if you use your two fingers right there, that's equivalent to right-clicking on a mouse. Alt. That's a right click. Thank you. See, you learn something new every day from your students. I tell you, that's why I stick around till I'm ancient, right? So I can keep learning all this technology. Okay, so if you notice your GeoGebra sheet, your yellow sheet talks to you about, there's probably more stuff on this yellow sheet than you'll ever need to know, but there's usually 3 views when you open up GeoGebra. The first 2 they give you are right here, the algebra view, and any equations you type, any points that you label will all appear in this column. Then you have your graphics view. Right here, you have your graphics view, which is your graph. And then you have a spreadsheet. And if you've never used a spreadsheet for Excel, I can show you a couple of things that will make life really very simple for you. But to get the spreadsheet, it doesn't appear when you open it up. You have to go up to the View menu, click it, and just put Spreadsheet, and then your spreadsheet comes here. So that's up in the View menu if you want to get all 3 of these. So what are we going to do? We're going to actually learn how to graph y equals 4 minus x squared. So the other important place you need to know is this little input button right here, this input bar. So you just come down here and you say y equals, pull up my keyboard here, y equals 4 minus x into square x. You hit the caret just like you do on your calculator, and then your 2. And you hit enter, and there's your graph. Okay? Now, on your calculator, you have to put in the x min and y mins and x maxes and y maxes and your scales to move this window around. Right now, I don't really care about the spreadsheet, so I'm going to get that out. This little thing right here, this 4-way cursor, allows you to move this around on your sheet. All right, so you can move it around. Put it in the middle, do whatever you want. You know, you can move it around with that. All right. Let's suppose you didn't want to go all the way out here. You wanted to shorten the values on your x-axis, and they only wanted to go from -6 to +6. Then you use that and you go right here and you just squish it like this. You can make this, look at how skinny you can make that look, right? Or how fat you can make it look. All right, so you can play around with the axes. See how wide that looks, okay? So this little 4-way cursor is really how you move around either on the page or you put it on your x-axis or your y. Once it turns to a double arrow, then you can reorient the scale any way you want, rescale it, okay? So that's a little cute thing to know. All right, suppose, what's the next thing I'm supposed to tell you on your handout? So we've changed the window to generate a table of values, open this spreadsheet, now type the X values you're interested into the column and program the formula into the column next to it. Okay, so if you haven't used a spreadsheet before, let's suppose you didn't want to plot all, you wanted to get some values. So later on you say, okay, What's the value when x is negative 3.12 or when it's 10.67 and you're too lazy, you don't want to put it in there, square it, add 4 to it, whatever the equation tells you to do. So you put in a number here. Let's put in one that we know the answer to. We know the answer to 0 is 4. And again, let's scoot this up so we can see that 4. All right, 0. All right. Numlocks, please. Thank you. Now over here, how a spreadsheet works is you can say, give me the answer to whatever is entered into this box by just copying in this formula. So you say -1 times, because that's what the dash in front of x. Let's start with this way. Let's do it this way. 4 take away. What's x? X is right here. That's A1. So you say 4 take away. I want to make sure I got the right takeaway here. Takeaway. Put parentheses, because you always got to put parentheses. And then you click on that cell, because that's the value. Squared. And there's your 4. Okay. Now what's really cool is you can increment this. You can go down here and say, let's just take whatever was in the cell before. Let's go up to cell A1 and let's add 1 to it. And now you just go shh, and there's all your numbers from 0 to 22. And now the same thing's going to happen here. This is the value when x is 0, but it's in terms of A1, and now it's going to increment and go find this value for y when x is 1, 2, 3, and you just go like this. And it fills it all in automatically for you. There it is. So that's kind of cool. All right. Suppose you didn't have this graphed already, and you wanted to put in a bunch of points. So let's go new, don't save. And I wanted to do that all over again. But let's say I just wanted to put in some points that I knew followed something in my head. Okay, so I say 0, 4, 1, 5, 2, 8, -1, 5. So I'm just following some rule right now, and probably some of you can figure it out what it is. All right, so there we go. Let's suppose I want to know what that looks like. This is the really cool thing you can do. You can click on that box, hold your left clicker down, highlight it, then right click right in the middle of this, go down to create and see where it says list of points. Boom, there are your points. So that's the beginning of a parabola that I was graphing. And if you want to get the coordinates for each point, you right click on the point and you go down to where it says show label. Oops. Excuse me, object properties. And you say, I think I just turned the label off. Is that what I did? You come down here, you want to show the label. And you don't want just the name like D, B, and A. You want the actual coordinates with it. So you just click on that, and voila, you can see the coordinates of that point. And if it's not in the right place, you just move it so you can see it. Well, I guess you can't see that too clearly, -1, 5. Okay, so again, that process is you click on the point, you go down to object properties, you go to name and say, I want the name and the value, and then you close out and it gives you the coordinates for every point. These things over here are called objects. So notice you have your 5 points, each with a different letter. Now let's suppose you wanted to enter a point and not do the spreadsheet. You can do it like this. You can say, okay, I'm going to call. Now, why can't I see these other points? Because I haven't squished my y-axis down enough. There are my other points that are over here. But let's suppose you wanted to plot, pick anyone, 9, 3. You can say, okay, G is going to equal 9, 3. And just enter it right like that in your input box, and there it is. So you can actually enter points individually, or you can put them in a spreadsheet like this, and then they can be plotted all at once. So it's really up to you. So if you notice at the end of your lecture notes today, you have two activities. One looks a lot like your first project. In fact, it is, except for we made a mistake on number 3. It says y equals 985. That should say 385 instead of 985. But actually, you can just put a big X through this whole sheet because it's your project. It's your green sheet. So you can put a big X right through this right now. Big X. We don't even want you to use that. And then the second part of today's activity is a little practice with your graphing calculator. I'd rather have you do that at home and see if you have any questions. And what I'd like you to do right now is to have some time to actually start your project, which is the green sheet. See if you can get all of your points entered, get going on it. You can save it if you want, because you're going to be entering your GCC information in, and you can save the file to Google Docs. And you'll be all set. You can use it later on by just entering your student information. Okay, so get your green sheet and you should be all set.